Yeah, today is Jesus is with us, and very nice to meet him. And he introduced himself and about his education and background. So please tell our people about you and the two ideas that how it can help our environment.
Okay, my name is Jesuso. I was born in Spain, and then I studied aerospace engineer, and then I moved to the Netherlands, where I have been working all my life as a patent examiner. But then I went to earlier retirement because I'm very worried and concerned for climate change. Actually, these days we have learned that in the coming 12 years, we need to do something fast because we are going to about to reach 2 degrees beyond pre-industrial levels. So with all this, I have found that we are not going to probably be able to reduce the levels of carbon dioxide to levels which are appropriate because there is not the political will. But there is another thing that can be a possible solution, which is recovering the water cycle. In other words, bring back the summer storms and the rain to the places where they have disappeared. For that, I have developed two ideas.
Yes.
One of them, the first one I will try to explain, is very amazing. I call it the rivers in the air. It's like imagine having a little river, a stream of maybe 1 cubic meter per second. And we are going to put it in the air, and it's going to fly with the air and evaporate
Mm.
in the middle of the air. If we are able to do it, and I have a technique how to do it, this evaporation of this massive amount of water will collect 2.4 gigawatts of energy every second
Wow.
from the
Mhm.
ambient.
Okay.
This is the energy of a small city.
Mm.
That is, the water is going to collect it from there. It will cool it. The air will go from 40 degrees to 20 and will go and will move in the breezes towards the mountains. But this air is already saturated. So it will move upwards, and when moving upwards, it cool a little bit further, will condensate, forming a cloud, and it will reach the top of the mountain. Hopefully, will generate a storm, producing rain and bringing back the rain to the arid and desertic places, which used to be fresh and lush before human intervention. Now, this sounds a bit like magic, but it is not.
Yes.
It's very technical. What I have found is that if you find a place where the air is moving naturally upwards, forming a vertical current, and you will say this is very strange. It is, but you can find the places. For example, around a cliff. If
Mm.
you imagine a cliff which is very perpendicular, and you have the sea breeze pushing in that direction, so this is the cliff, and this is the sea breeze. The sea breeze is going to deflect upwards because it's trying to bypass this obstacle.
Yes.
And when it is in this situation, I have been there with my anemometer and I have measured the direction of the wind. The wind is perfectly vertical and moves at speeds of 5, 6, 10 meters per second. This is about between 20 and 30 kilometers an hour. Well, in these places, you can dispose an nebulization of droplets. And if the droplets are very simple, not very, very tiny even, so 0.5 millimeter, for example, they will move upwards with the wind and they will
Okay.
evaporate. This is a bit the principle.
Mm.
I would be happy to show all these with pictures and diagrams and some experiments that I have made. This is one thing that we can do to cool the ambient strongly.
Very
The
exciting.
cooling, yeah. So as I said, 2.4 gigawatts of energy disappears from the ambient, cooling it
Mm.
from 40 to 20 degrees.
Wow.
And all this energy is now in the water in form of vapor. All this energy will be given back at the top of the mountain, maybe at 5,000 meters high,
Mhm.
forming a cloud. The, the, the heat changes again from latent heat into sensible heat. And there it can radiate to the stratosphere because you have passed the level where the greenhouse gases are. So this is a phenomenal tool, cool the ambient. Not mentioning that when you have a cloud, the cloud doesn't allow the radiation to come in, so it increases the albedo locally. So it cools. Well, everybody in the south knows that when you have a cloud in the middle of the summer, this brings freshness.
Yes.
So this is the first one.
One.
Yes.
Yes. And what about the phase two? You are talking about the two. The one is interesting. Awesome.
I have a second idea, always based on the same principle, based on the power of the water. The water is we say water is a miracle. Water is linked to life.
Yes.
Some of us have this strong, but there is so many things of water. We drink it every day, but we don't know it well. Because water has this huge capacity of cooling.
Yes.
And this is one of the most important things water does in nature is cooling. When the trees cool you is because they are evaporating water. And again, I use the same effect. I try to use tools that produce very enhanced and very powerful evaporation. And one of the best ways to do that is to transform the waters in tiny droplets, because a droplet has a big surface compared with the volume that it has. I've made some nice calculations, but if you make droplets of a tenth of a millimeter, then 1 cubic meter can have several hectares of surface, and then it can evaporate very quickly. So I have done a similar thing, but now the movement is not upwards, it's downwards.
Okay.
There's some advantages. Imagine I built a very simple structure is like a pipe, a cylinder, open in both sides, at the top and at the bottom. It has to be rather big. I've made several prototypes. I made one in Madrid 2 years ago, and I put it to work in the middle of a heat wave. Imagine the weather was about 42 degrees centigrade and 15% relative humidity. So I hung this pipe, which was 2 meters of diameter by 10 meters of height. I hung it from a big tree. And at the top, I produced a nebulization. So what happened is, because it was so hot, the droplets were very tiny, very quickly they evaporated. And when they evaporated, they cooled the air, which went from 42 to about 20, rather quickly, or almost 20. What happens then is, because the air, you know that air, when it is hot, it expands.
Yes.
And when it is colder, it contracts. So now, because my air is colder, it is now colder because the water has extracted the heat. It's also denser, so it weighs more than the other air, which is at 40 degrees. So imagine you have at the top of your tower, your cylinder, air which is denser, and because it is denser, it falls.
Yes.
So normally, exactly. And normally the air will fall, forming eddies, and this energy will disperse. But because it's inside a pipe, it cannot form the eddies, and it's organized a wind. Forms naturally without any propeller. You have a wind moving from the top down.
Yes.
And this wind acts as a siphon. So when it comes down, it pulls more air from the top.
Continuous phenomena. Yeah.
So it will go down, and when you are down, we were actually the cylinder was above our heads. So we had this breeze of cold air, 20 degrees. We were in the middle of a heat wave. So it was like being, everybody wanted to see it, and you can feel the power of this cooling. And this is, it was very powerful, because I think we were evaporating about a bit more than 3 liters per minute, which is equivalent to 140 kilowatts of cooling.
Wow.
If you in your house want to evaporate 3 liters and a half of water, which is like a pan of water, you will not be able to do it in 1 minute. It will take you a couple of hours. That is because in your house, you don't have 140 kilowatts. You have typically in a house, you have 2 or 3 kilowatts maximum, or in your kitchen, certainly.
Mhm.
That's what the power of the evaporation was. And I have, thanks to my studies of aerodynamics, I know that if I made this tower bigger,
Mhm.
the the efficiency will be even strong. The wind falling down will be stronger, and the cooling impact also bigger. So we
Yeah,
could use this kind of towers to cool, for example, a park or a square in a city
yeah.
or a place where in the middle of a heat wave, you could cool the exterior. You don't need to go into your apartment and put the conditioning. You could be cooling the ambient for the people.
Wow. I learned a lot, like in our majority of the parks, some like gravity, waterfall, or this. If we convert this with this one, the increasing the surface area of water and the tiny drops, and
Yes.
it's a cooling effect.
Yes. Think there are many ideas of spraying water in the middle of a heat wave, and they
Mm.
are if you are in a place like in Pakistan where the ambient is very dry, they work
Yeah.
relatively well. But problem is that in order to make a lot of evaporation, you not only need water, you need also a lot of air. And I'm going to ask you a
Yes.
question, Abdul.
Yes.
If I have here a liter, a bottle of water, which is empty.
Yes. Yeah.
Imagine I have this with water,
Yeah.
and I want to evaporate it completely.
Yes.
Okay, how much air do I need?
Lot of air and lot of energy.
You
We
need a
need
lot
to
of air,
make
yes,
aerosol. Yeah.
and a lot of heat.
Yeah.
And more or less, the answer is, of course, depends a bit of the conditions of the ambient, but it's about 100,000, between 100,000 and 150,000 times more volume.
Mm.
So you need a huge amount of air to
Yes.
evaporate the water. So this
Yes.
is the problem of these sprays, sprinklers in the city. They bring the water, but there is not enough air. So the majority of the water does not evaporate. It falls down to the ground and it doesn't cool very efficiently. But if we have a system like my idea, but there might be other ideas or even better ideas, where you are able to mix the water with the air before it falls down, you produce a huge cooling effect. And this heat is going to go away. And as I said, the destiny of this heat to become sometime a cloud, which will bring rain.
Yes.
And also, once it is a cloud, will cool the ambient. So I'm a strong believer that these evaporation systems can help us fighting climate change, or at least
Well,
help us buy some time uh, to before we find maybe better solutions.
yeah. Yeah, really awesome. And the both phase one and two, very interesting and very great learning, especially for the people who are living big population and have a very expensive energy. And for our audience as well, and learned a lot. And we'll upload it for 31,000 followers and viewers across the world, like in Africa, like in Pakistan, Bangladesh, India. If they can follow up and they can have practice it on small level and on larger level scale as well.
Abdul, both the tools could be used depending on the place, of course, with seawater. Because in
Yes,
some places, in some arid places, the problem is that they don't have sweet water. So they can, as me Jesus, your tool needs a cubic meter of water per second, but we don't have water at all. Where are we going to find the water? Well, we can get the water from the sea, particularly for India, Pakistan, for example. If you nebulize this huge amount of water, you are going
yes,
to produce a huge amount of aerosols, salt
yes,
aerosols
yes.
that could do the cooling when you will remove the high levels of contamination that you have at the moment. And these aerosols are so good because they form they call it um, uh, condensation nuclei for raindrops. You know,
Yeah,
when rain forms, it condensates around a little nuclei. Typically, it could be a grain of sea salt.
yeah. Like I learned from you that in Spain, sea and the 100-kilometer area is a mountain. In Karachi, our coastal line is a 30 million population city, one of the top 10 world city, metropolitan, a large, huge city. So we have this sea one side, and other side, if we make some artificial height or like mountain, we can have the same phenomena of cooling and collection of water.
Yes, yes. I mean, all the whatever you are, wherever you evaporate water, you produce this cooling. And if you have do you have winds moving in Karachi? It's a flat land, eh? Until
Yeah,
you
it's a
reach the
flat.
mountains,
Yeah,
flat land.
yeah, yeah.
Okay.
And
Uh,
I will study this and once go there. It's 1100 kilometer from where I live, and we'll share some thing that phenomena. And you can even get from the Google. And it's wind is always across the year. Some days there is no wind, but it's always from sea to city, and we can use this phenomena to cool and to collect even drinking water, like it's full of moisture, and relative
yes.
humidity is about 70 or 80%. So thank you very much, my friend, and really glad to meet you and learned a lot. And we'll have connect again in some panel discussion, from the Germany, from the Ireland, from Switzerland. All the stars are there, and have healthy discussion on climate and water. Next is
Cool. It's a
so.
pleasure to meet you. I am
Thank you.
happy to find people that are wishing to help
Yeah,
solving the problem or
welcome.
other problems. And I am a big believer in different people from different parts of the world engaging for the good of all of us.
Yes, thank you very much. Thank you very much. Take
Thank you.
care.
Bye.
Bye bye. Yeah.